this presentation came out of conversation I had with Randy Warren a number of months ago. We were talking about beam power tubes and how the 6L6 tube was the grandfather of all beam power tubes, and how they are still being manufactured today. One of the few tubes that are still being manufactured and alive and well and in use in lots of current day audio and in guitar amps, etc. So, and okay, got it. So let me just step through this. And before I really start talking about beam power tubes, I want to give you a little basic lesson in tubes in general. Okay, so a little tube basics 101. All right, and so to start off with, we go back to the diode. Yeah. All right. I'm not sure how to get rid of that. Why don't we do? What's that? I can't see it though. Here. Maybe I can see it from here. No. I can drag this. That better? Can I drag it to the side? How about I drag it off the screen altogether? Yay. All right. That's fine. I can move it over there. All right. Okay. There. Sorry, folks. Technology. So anyway, the diode, invented by a fellow by the name of Fleming, John Ambrose Fleming, in 1904. He found that he could set up a tube that had a cathode and a plate or an anode, and that he could get current to flow in one direction only. Okay, and therefore we're looking at a rectifier. Okay, and that's what a diode's all about. So there's no signals in here. You put power into it, you get DC out. Okay. Next step was we had Lee DeForest was messing around with his diode, the Audion diode, and he realized that if he put a grid in there, and he put some power to the grid, that he could actually control the flow of the electrons in the tube. And this was the first triode, all right? And the triode allowed for a small change in voltage on the grid, produced a large change in both amperage and voltage on flowing through the tube. So this was essentially an amplifier. And that was the first time that came about in 1907. So triodes were used in radio transmitters and receivers, and it was found that the tuned amplification stages had a tendency to oscillate unless their gain was very limited. And this was due to parasitic capacitance between the plate and the control grid. All right, so that was, triodes worked great, but they didn't work ultimately great. Okay, they had their issues. Triodes are still in use today. 12AX7, 12AU7, they're all triodes, but they're not amplifier tubes. They're used for various other functions, or not final stage amplification. So we said we needed more power. So they went to they realized that there was a fellow by the name of Schottky, and Walter Shockley, excuse me, and he invented the tetrode. He put a screen grid in the tube, an additional grid, and this shielded this acted as an electric static shield between the control grid and the plate, and solved the capacitance problem, or at least it reduced it drastically. The added grid became known as the screen grid, and operates at a positive voltage that's less than the plate voltage, and was bypassed to ground with a capacitor of low impedance for at the frequencies to be amplified. So the decoupling of the plate and the control grid allowed this tube to give much better gain, voltage gain, than the triode. But it did have an issue. The cutaway that you see here is actually the first commercial triode, which was made by MOV, or Marconi Osram valve, and it was the S625, and was we see that screen grid tubes were marketed by late 1927. Okay. So next, said the problem with the tetrode was a shortcoming in that secondary electron emissions from the plate could cause a tetrode kink. That's what they called it. The tetrode kink actually looked like this range here, a region of negative resistance. So the tetrode had limitations. It would only operate at voltages where the plate was higher than the screen voltage. Okay. Otherwise, anything below that would have a negative resistance, or this kink in there. So that was kind of an issue. Tetrodes had limited range of operation. But they did have a tremendous or much better gain than the triodes. Okay. So what's the next step? The next step, they added another grid. Okay, the suppressor grid. This was done in 1926 by Bernard Telligan, and the result was the pentode. Okay, 5 electrodes, 5 elements, pent for 5. Okay, the pentode. And as you can see in the cutaway here, we have on the outside the plate, the cathode on the inside, the control grid, the screen grid, and then the suppressor grid on the outside of that, as depicted in the element here to the right. So now the suppressor grid of the pentode was usually connected to the cathode, and its negative voltage relative to the anode repelled the secondary electrons, so they wouldn't be collected by the plate, and or they'd be collected by the plate, and it was much better than the tetrode. And so as a result, you come up with these nice little curves showing amplification and no tetrode kink. So the pentode was far better than the previous tubes, but again, there was some development going on where we went to the beam power tube. Okay, now the beam power tube is also known as a beam power tetrode because it only has 4 elements. It doesn't have the suppressor grid. Instead, it uses beam forming plates, and instead of just emitting electrons in all directions like a normal pentode or a triode, it emits them in a beam. Okay, and the beam is, as you see in the cutaway here. And by the way, on the left is the is how they configured the schematic for the tube. So you see the beam forming plates there. In any case, the beam power tube. What's with these beams? Okay, well, using these beam forming plates as well as the structure, unique structure of the tube itself, where the grid wires and the beam and the screen wires were perfectly aligned. Okay, so that the beam really never really hit the screen grid control wires, because if they did, it could have actually burned them up. They were in the shadow of the control grid, and it turned out that they also used this space charge along the plate here to create a new type of tube. And this tube had the ability to put out tremendous power and great gain. And the cutaway here, you can see that there's the grids, there's the beam forming plates to the left and the right, and the plate has been cut away so you can see inside the tube. But the plate is very heavy on a beam power tube. The reason being is if the beam were to hit the glass, it would bore a hole in it. Okay, the plate actually had to absorb all those electrons and keep the tube intact. So the features of a beam power tube were it had no triode parasitic capacitance issues. It had no secondary electron tetrode kink because of the effective suppressor action provided by the space charge, and because of the low current draw by the screen grid. The beam power tube had the advantages of high power output or transconductance, high power sensitivity, and high efficiency over other tube types. So although it was considered a tetrode because it only had 4 elements plus the beam forming plates, it was in many regards as good, if not better, than the pentode, more energy efficient than the pentode. It also had lower third harmonic distortion over comparable pentodes. So you can see the factors relative to that here. So are they tetrodes or are they pentodes? Well, it's interesting because in the top diagram here, that came out of the 1940 RCA tube manual. It shows the beam forming plates, those little black items pointing towards the center there. But in the 1947 RCA receiving tube manual, it showed it as a pentode. Okay, so in reality, the manufacturer data sheets often use the terms beam pentode or beam power pentode instead of beam power tube or beam power tetrode. Okay, so it was kind of like, you know, really without any change to the tube itself, we had a new diagram being used. Okay, and part of that was in line with the fact that the patent on the beam power tube expired, so now they could call it a pentode instead of a tetrode. Right? But so what? How did these beam power tubes come into being? In 1933 and 1934, there were some patents filed by 3 electric and music industries, or EMI, engineers in the UK. They were Isaac Schoenberg, Cabot Bull, and Sidney Rhoda. And EMI, by the way, was also known as EMI Records, a transnational conglomerate founded in March of 1931 in London. EMI later manufactured records for the Beatles. Okay, so bringing it up to date a little bit. In fact, I heard a story, a little sideline story. EMI was involved in developing CAT scans. You say, what? When EMI started selling Beatle records, they made a fortune. They had more money than they knew what to do with. And so they told one of their engineers, go do whatever you want. And he actually studied x-rays and figured out how to do CAT scans, and it came out of EMI records. All right, but the uh, the thing that their patent identified was that these tubes had some significant capabilities, and we already touched on most of them. The grids were aligned. They had the beamforming plates. They put out a lot of power. And so actually MOV, the Marconi Ostrom valve, built 1,000 of these things and exhibited them at a show in 1935. But they figured out they were really hard to build because they had to get these grids exactly aligned. And being that they already had a share agreement, a design share agreement with Radio Corporation of America, or RCA, they passed that on to them. And as a result, RCA developed the 6L6 tube. Now, the 6L6 was the first commercially viable beam power tube. And it went into production in 1936 and was very successful. It was used extensively in high fidelity audio amplifiers and musical instrument amplifiers, and is still being used in those today. Okay, not exactly the metal ones, but 6L6 tubes are still out there and being manufactured. The technology. Well, the actual original tube was in a metal case. That was something developed by GE and introduced in 1935. RCA manufactured the envelopes, and it came out with a octal base, which also came out in 1935 with the metal tubes. The 6L6 and its variants became very popular in use in public address amplifiers, musical instrument amplifiers, radio frequency applications, as well as in audio stages of radio transmitters. Now, a couple of little interesting factoids here. There's a tube called the 1614. If you look on the base of the 1614, it says it's a 6L6 because all it was a 6L6 that passed a special radio frequency test, and 95% of the tubes they tested passed that test. So almost all 1614s are in fact metal 6L6 tubes, but not all metal 6L6 tubes passed the test, but most of them did. There was also a tube called the 1622. Again, it was just a specially selected tube. They would select a number of metal 6L6 tubes, and they said, oh, these have lower noise. So they use those in theater sound systems and designate them as the 1622. The 6L6 family has one of the longest active lifetimes of any electronic component, period. It's been around for more than 80 years, and variants of the 6L6 are still being manufactured in Russia, China, and Slovakia. Okay, 6L6 variants. Well, this is kind of like the timeline for the 6L6. Started off, there were many different 6L6 tubes, including the G, which was a glass envelope, the GX, the GA, the GAY, the GB, the 5932, which is also the 6L6 WGA, and the 6L6 GC, which is still very popular tube. Almost all of them put out 19 watts of power, but after the metal tube, all of them were in glass envelopes. The 6L6 GC tubes were used extensively in Macintosh amplifiers, ICO amps, Heathkit amplifiers, plus a lot of guitar amps. All variants of the 6L6 used glass tubes. By the way, the W descriptor meant that it was withstood greater vibration, and the Y meant that it had a Myconol base, okay, instead of the normal the base was normally, Bakelite. Yeah, that's the term. Yeah, that's the word I was looking for. All right. 6L6 derivatives. The 807 was probably the first one to come out. It was a redesigned 6L6 using an ST16 bulb, put out about 30 watts of power, and was used in a lot of different um, uh, power applications, including some World War II Navy sonar systems that used 6 of them. By the way, the 1946 ENIAC computer contained 350 of these 807 tubes and 3,500 6L6 tubes. The ENIAC used a lot of tubes. The 807 led to the 12-volt variant of the 1625. Now, 12-volt was much more adaptable for mobile applications, and it also had a lot more power, 40 watts. It was used extensively in World War II communications gear. And then also came out in 1946, they came out with the 6BG6, which are ubiquitous. There's thousands of these made because all the 1940 TVs from all the TVs in the 1940s used 6BG6 tubes as a sweep tube to generate the image on the cathode ray tube. So these were all based on the 6L6. They're all beam power tubes, and let's move on. We've got a number of audio beam power tubes out there. The 5881 was designed by GE and put out about 23 watts. They used them in Bell, Bogan, Heathkit, Fisher, and Fender Bassman amplifiers. The Tungsel came out with a 6550, and it put out 35 watts, and then later the 6550A, 42 watts of power, used in a whole bunch of different amplifiers by Altec, Macintosh, Scott, Harman Kardon, Fisher, Ampeg. GE came out with the 7581 tube in 1959, put out 30 watts. It was the tube used in the Harman Kardon Citation 5, which was very popular. Then in 1960, Westinghouse developed the 7591, and that was used all over the map. And the reason it was used all over the map, even though it only put out 19 watts, was it was really low cost. A 6L6 tube at the time was going for like $20 or $30 a pop, new, and these tubes were being sold for like $3 or $4. They brought the production costs way down. And so as a result, it was in all kinds of different amplifiers, including Ico, Fisher, Harman Kardon. It was not a wimpy tube. It was made very efficiently and at lower cost. And then you take the 7591, put it in a Novar base, and you have the 7868, which was used in Fisher and Sherwood amplifiers. So these were all very popular audio tubes and are still very much sought after today. Other beam power tubes that came out, the 6V6 had a line that was used in a whole lot of different amplifiers as well as in radios extensively. It put out 14 watts of power, and it started off in glass, then went to metal, and then went to the GT. And then we saw that there was a variant of it that was aloctyl, and they basically took the same tube, put it in a miniature envelope, and it became the 6AQ5, which is also very ubiquitous. I've got hundreds of those in my collection. Next was I'll call it the L6 family. These were used across the board in the All-American 5s. Okay, and there were various various filament voltages of this tube, but essentially they were all the same. The 12L6 GT, the 25L6 GT, the 35L6 GT, etc. Were all put out about 10 watts, except for the 35, a slightly different design, only put out 8.5. But almost every All-American 5 has these. And then they made them in miniature, and the 50C5 and the 35C5 were examples of that. And that came out in 1948. So all of these tubes are beam power tubes. Again, audio sweep tubes. Now you hear about these sweep tubes. We saw earlier the BQ6 was used in the 40s TVs. Well, as TV progressed, they needed stronger and better tubes to handle this sweeping of the cathode ray beam. So, and then particularly in the 60s with the color TVs, there were even more. Essentially, these tubes were putting out as much power as some of the audio tubes. The 6LF6 puts out 40 watts of power, and they were readily adaptable into things like the single side or yeah, they had single sideband linear amplifiers. Sometimes they used a number of these and put out thousands of watts of power with relatively cheap tubes. Okay, and they were also used in high-end audio. And the ones you see here, I'm not going to go through each one of them, are all used in high-end audio that is currently pretty well sought after. And we also have to realize that beam power tubes have another name, okay? And that other name actually comes from a designation called KT, which means it's a kinkless tetrode, okay? So, and that meant that these beam power tubes had no kink like the normal tetrode. And what were some of the kinkless tetrodes? Well, it started off with the KT66. Actually, didn't start off with that, but that was very popular. This KT66 is very, very much similar to a 6L6WGB, and the 5881 puts out about 25 watts power. KT77 in 1960 came out, 32 watts of power. It was used extensively in Marshall amps and Acrosand amplifiers. KT88 came out in 1956. Essentially, it was 6550, put out 42 watts of power, used extensively today. These are highly sought after. In 1990, the KT90 came out as a replacement for the KT88, put out 50 watts of power. And my buddy Paul Hart loves this one. The KT120 puts out 60 watts of power. It was came out. It was marketed by Tungsol, but made in Russia. Okay, not the Tungsol that we knew from New Jersey. Anyway, these were popular KT tubes. So sometimes they took two beam power tubes and put them in the same envelope, and they all the VHF push-pull tetrodes of World War II were beam power tubes. That included the 815, which I got one yesterday at a flea market, a ham fest. The 829, actually at one point the development of this tube was considered top secret. And it put out 40 watts of power. It had two 6L6s in there. And the 832 was essentially a scaled down 829 and put out 15 watts of power. So these weird looking tubes were all used extensively in World War II transmitters and transceivers. Well, You know, in some cases, there's more than one way to skin a cat. Um, Many people are familiar with the EL34. It's a pentode, a true pentode, and you can see it was long and skinny, and here it is to the left. But the folks over here in the U.S. Developed the 6CA7 beam power tube, and you can see that that is a beam power tube from the massive plates that are in there. Electrically, it's identical to the EL34, but it's a beam power tube, not a pentode. The KT77 is also a beam power tube, again, equivalent to the EL34. But even back in 1937, a KT63 was put out, and it's identical to, electrically, identical to the power pentode, the 6F6G. And also the 6BQ5. If you're into audio, you're very familiar with that. It's used extensively. It is, its manufacturing history goes back and forth. It actually, they sometimes made it as a pentode and sometimes made it as a beam power tube, and back and forth multiple times over the course of its manufacturing history. So there's always more than one way to skin a cat. And it's kind of interesting that you could take and test an EL34 on a tester and use the same settings and test the 6CA7, and they both will test under the same. And it's like these tubes work identically, okay, but totally different manufacturing process. And so then I had a number of references, and that's the end of my presentation. So who's got any questions?
You mentioned that the different wattages of similar tubes. What was different in their design or manufacture that gave them higher wattage?
Oh, but just the way that the beams were structured, the way the plates were structured. Sometimes it was even included the coloring of the plate, getting it ultra black. A number of different factors used to increase the power. Okay, Steve Hansman had a question online.
Yeah, can you hear me, Dave?
Yeah, I'm going to turn you up a little bit. Hang on a second. Go ahead, Steve.
Yeah, just a comment about what you said about EMI and CAT scanners. When I was a third-year medical student in 1977, while I was on my neurosurgical rotation, University of Maryland Hospital got their first CAT scanner, but it was not called a CAT scan. It was called an EMI scan because manufactured by EMI.
Okay.
And at the time, the only thing it would scan was the skull, the brain, and you didn't get any kind of digital picture or X-ray film. You got the equivalent of a Polaroid that it would print out. That was about 4 by 4 inches.
Okay. Well, anyway, that verifies what I had to say. Okay. Very good. Thank you, Steve. Are there any other questions? Go ahead.
Yeah, my question is, I see tubes listed on eBay and they'll say like black plates, gray plates. To me, a tube is a tube. So is there really a difference, or is this just for folklore?
A lot of it is hype. You can just leave it on. A lot of it is hype. Sometimes it's just a descriptor. There are folks who will swear that their ears can tell the difference between some of the different tubes. Mine are pretty shot. Okay, my ears, my hearing got taken out by a shotgun that went off near my ear when I was a kid. So I can't tell the difference. But some folks swear they can, and they'll say that this, this particular tube sounds much better. And they got all kinds of descriptors for it. Maybe it sounds better. That doesn't mean it's actually reproducing what was supposed to be reproduced any better. Why do all stereos have tone controls? Increase the treble, increase the bass. I don't know. It's a matter of aesthetics, I think, more than anything. But if it helps me to sell a tube, I'll be glad to talk about it. Any other questions, comments? All right. Well, thank you very much, folks. Appreciate it.